Glad to be here. So just imagine, just 100 years ago, if a baby was born in this country, then she was supposed to live only up to 45 years of age. And then now, you fast forward, maybe 2018, and if a baby is born, she is going to live up to 79 years. So how do you think that miracle happened? So almost 100 years ago, most people died of infectious disease that are caused by pathogens. So every year of biomedical research contributed almost 3 months to human longevity. So over the last 100 years, we gained that longevity mostly because of research in antibiotics, vaccination, sanitation, etc. And even nowadays, no single surgery, no single treatment goes without attention to sanitation, vaccination, or antibiotics. But the problem is, living longer doesn't mean living a healthy, long life. We spend almost half of our life right now fighting with chronic diseases. And most of these chronic diseases are not caused by pathogens, but mostly due to bad lifestyle choices that we make. And there are not enough cures because we know that for every person that they treat, the top 10 highest grossing drugs in the US do not help 3 to 24 people who take them. So that means we need a completely new idea about what causes disease so that we can start a new revolution in finding new treatments or finding new preventative strategy. So in that context, I want to introduce you to the idea of circadian rhythms. So most of you will immediately relate circadian rhythms to sleeping and waking cycle, and that's only the tip of the iceberg. In fact, if you're lucky and you went to bed around 10 o'clock last night, your deep sleep happened around 2 to 3 o'clock in the morning, and anticipating waking up, your body started to warm up a couple of hours before you woke up. And then as you opened your eyes, got some bright light, then your melatonin level, this sleep hormone melatonin level drops, your stress hormone or cortisol begins to rise, and that's also the time when your digestive system is the best, your pancreas is best, and you can actually consume a sugar-rich, good breakfast. And in the middle of the day, your brain functions the best, and around this time, actually, your muscles have the best tone, so this is the best time to exercise. And as the evening rolls in, your melatonin level will begin to rise, your body will cool down, and you'll go back to sleep. And this happens on every single day. In fact, to have these rhythms is to be healthy. These are the signs of vigor and vitality that happens to us. And these rhythms, nowadays we know that these rhythms are mostly driven by circadian clocks that essentially drive 3 foundations of health: sleep, nutrition, and physical activity. They time them, and these also have different interactions with each other, and finally all these rhythms are under the control of light and darkness. So in this context, if we think of what we are doing that's so different from our ancestors, it's easy to imagine. Almost 100 years ago, up to 100 years ago, our ancestors had different rhythms. Throughout the day, they had access to bright light, and nights were completely dark. So they could actually sleep, restful sleep, for at least 6 to 8 hours. And then during daytime, there was a lot of physical activity to produce that food, to get that food. And then there was very little opportunity to eat because food was scarce, and then night was very dark, so people ate most of their food, mostly within 10 to 12 hours. But things changed all 110 years or 150 years ago. So modern rhythms are very different. We spend most of our day in dimly lit room like this, and our nights are also quite bright, so we spend mostly 4 to 6 hours, if we're lucky, in sleep. And our physical activity has gone down, and our opportunity to eat has gone up. So in fact, as long as our eyes are open, our mouth is open. And we are told that we have to eat in every 2 to 3 hours, otherwise our brain will stop. So what happens is when we have this disruption to our natural light-dark cycle, sleep-wake cycle, and physical activity and eating rhythm, then that disrupts our circadian rhythm. And just a few nights of losing sleep doesn't do much disease, but we know that we feel horrible, we feel bloated, we feel sleepy, we have completely lack of energy. And if it continues for weeks, months, or years, then they bring us close to many chronic diseases. And in fact, if you do some literature review, then you'll find more than 100 different diseases. The risk for those diseases go up as there is chronic circadian rhythm disruption. But one thing that we always forget, we think circadian rhythm disruptions happen only to shift workers. But the definition of shift work that causes circadian rhythm disruption leading to disease is very simple. One has to stay awake for 3 hours between 10 p.m. and 5 a.m. for only 50 days in a year to have that kind of disruption. So that means weekly once, if you're staying awake within those 10 p.m. to 5 a.m. for 3 hours, that's enough to disrupt our rhythm. And we can see that how widespread those disruptions are. And it's not surprising that the diseases that are in red affect more than 10% of the population in the US, and those in yellow affect 5% of the population. So then the question is, how does the system work, and what do we know how to bring it back? So just like most of you can imagine that we have a clock in our brain that tells us when to sleep, when to wake up. Surprisingly, over the last 10, 15 years, what we have discovered is almost every single organ in our body, even every single cell, has its own circadian clock. And the brain clock just synchronizes all these clocks so that all these, when they work together, then we have daily rhythms in almost every hormone, every enzyme, every brain chemical, even every single gene in our genome has to turn on and off at a different time of the day or night. And when all of these work together, then we have daily rhythms in physiology, behavior, metabolism, and even in our gut microbiome. Then the question is, how are these things connected to the outside world? So a long time ago, people realized that these are all connected through light that's perceived through eye. And we knew that light goes through the eye and then trains this clock so that when there is daylight saving time, changes happen. That happened a couple of days ago. Or when you travel from one time zone to another time zone, then we can re-entrain our clock to the new light-dark cycle. The exciting thing was, and for us, was just any light will not do it. Almost 16 years ago, around this time when my daughter was born, we discovered a new light-sensing molecule called melanopsin. It's a blue light-sensing protein present in only 5,000 cells in each human eye, and these cells are directly hardwired to the master circadian clock in our brain. And what was interesting was these light-sensing neurons are less sensitive to candlelight or moonlight. So as a result, when our ancestors were sitting having a fireside chat, this melanopsin was sensing no light and was telling the brain that it's already dark, go to bed, and melatonin was rising, they went to bed. And during daytime, these sensors need a huge amount of light to activate. So as our ancestors walked outside, they had bright daylight that activated melanopsin, re-entrained the circadian clock, and synchronized the brain clock, raised alertness, and reduced depression. So this fundamental idea about circadian clock and melanopsin is changing how we look at life. And I'll now let Marty explain.
Hi there. I want to thank Dr. Panda as well as Daniel Kraft for including my piece of wearable art that is based on Dr. Panda's work at the Salk Institute. So I call this ensemble Night Visions, and every part of this ensemble was based on the scientific research that you're doing. And it explains how the neural network of the melanopsin retinal ganglion cell is communicating with the brain to regulate a mouse's circadian rhythm. So I'll start with the hat. And I made the whole ensemble myself. The hat has a Gregorian sea fan on the top, and under black light in certain conditions it fluoresces, and that represents the retina of the eye. And then the two white globes on the hat represent the two globes of the eye. I chose black silk organza to represent blindness, and then in the blouse it's layered with 2 layers of white organza underneath, which gently fluoresces under black light, and that represents night and day, as well as, again, the circadian rhythm. And it also represents blindness, because that is the basis of your research. And then when you look at the cape, which has a somewhat 3D quality to it, as well as the skirt. The pattern is based on, you can see, the research of this biological slide. And this is a slide that represents a greatly magnified melanopsin retinal ganglion cell. So I used different colors of thread when I was sewing the skirt and the capes, as well as the earrings, and each color I used represents a single cell line. And it was great fun to collaborate with Dr. Panda and work with the Salk Institute, and it's really lovely to be here tonight.
Yeah, so these images are actually from three-dimensional electron microscope images of melanopsin cells. And I had an MD PhD student in the lab who collaborated with the artist to bring these to life because they were so beautiful when she was reconstructing them, initially manually and then using some modern AI technique for image processing. That was very inspiring to see how this simple design in melanopsin ganglion cell can be inspiring in design. Okay. Thank you. Thank you. But the challenge now is we spend most of our time indoors. So in the night, we have bright screens and bright light, just like now. That activates melanopsin because this melanopsin system gets confused whether it's nighttime yet. So it disrupts circadian rhythm, and it tells the brain it's not night yet. So melatonin level never rise up. And we have sleepless night. And then during daytime, as we spend most of our time indoor, for example, right now, there you have nearly maximum 50 lux of light, whereas in a cloudy day outside in San Diego, you'll get 10,000 lux of light. So that misaligns our circadian rhythm, reduces alertness. We have foggy brain, so we switch back and forth between insomnia and foggy brain and fight it with caffeine, but that's not enough. And if it continues for several days or months or weeks, then we get close to many of these diseases. So this very simple idea that lighting for health is not same as lighting for vision is starting a new revolution in lighting to promote health. Just imagine kids who are sitting all day in dimly lit classrooms and going through circadian disruption. It's having lifelong impact on their brain development. So this idea has led to a new revolution, and the first glance of that revolution is when 3 billion cell phones and smart screens now dim down around 10 o'clock at night and change the light color. And I'm so happy that my 16-year-old has that technology now. But that's just the tip of the iceberg. So imagine circadian lighting that will sense our circadian rhythm and will brighten up the day. And as the day comes to an end, it will slowly tune to orange color or darkness at night so that we can have a restful sleep. That will promote learning and brain development among kids. And circadian lighting at home, offices, or factories will improve productivity. And circadian lighting in hospitals and retirement homes will improve healing and rejuvenation. But at the same time, we know that light is not everything. A few years ago, we stumbled on this idea that, well, when people stay awake late into the night, they're not sitting in this empty living room or kitchen like this. They actually are living in this environment where they have access to light and access to food. So we asked what happens when food is presented at the wrong time. To make all these complex things simple, when we eat at the wrong time, the food overrides the control by light. And it tells our circadian clocks and all these peripheral organs that this may be day. So as a result, this circadian disruption can lead to disease. So we asked, is it true? So we wanted to do a very simple experiment. So we took two groups of mice, identical set of mice, born to the same parents in the same room, had the same microbiome, same genetics, same age, and same gender. We gave them the same food every single day, and they ate the same number of calories every single day. The only difference was the first group of mice got to eat whenever they wanted, and the second group of mice got exact same calories, but initially they were trained to eat only for 8 hours every day. It continued for 18 weeks. Every week we weighed the mice and weighed the food. And at the end of 18 weeks, it was surprising. The first group of mice were obese and diabetic and fat. But the second group of mice weighed 28% less, and most of that change in body weight was due to reduction in adipose tissue or fat mass. And we went back and repeated this experiment again and again. And we gave them different types of eating hours, 8, 9, 10, 11, 12 hours. Sometimes they even got the weekends off. There are different diet, high carb diet, high fructose, high sucrose, even high cholesterol diet these days. And we always saw the same thing, that the mice that eat within 8 to 12 hours max always remained healthy. Not only that, if we take sick mice that were already morbidly sick and put them in 8 to 10 hours diet, then we could reverse disease. This was really surprising and earth-shattering for us, because last 100 years of nutrition research has taught us count calories and look at composition of your food. What we're finding is just timing, controlling timing, is much more powerful than any single drug that's available, even to treat these sick mice. So then we wanted to see, how does it translate to human? So only 3 years ago, we started this website called mycircadianclock.org, where people can go sign up, give an informed consent, and then download an app called My Circadian Clock, and then log when they eat. They share their data, some of the health data. And what we found, surprisingly, is what you're seeing here in concentric circle are 156 people's eating time. Each single dot is one eating event. So what we're finding, people who don't do shift work, who have a regular 9 to 5 jobs, 50% of them eat for 15 hours or longer. So that means if the first sip of coffee with cream and sugar happened at 6 a.m. in the morning, then the last sip of beer happens at 9 o'clock or later. Then the question was, well, can we take some of these people and ask them to adopt a simple behavior that's eating everything within 10 hours? Because you can come up with many different modifications, behavior modifications, not all of them stick. So that was a big reckoning moment for us to test this. We call it time-restricted eating. What is interesting is over the next 10 to 12 weeks, people actually adopt this and reverse many conditions. Over the last 3 years, we have nearly tens of thousands of people from all over the world sharing their data. And what we're finding is it's relatively easy. Of course, it needs some personalized guidance sometimes. And within 10 to 12 weeks, they begin to see improvement. They feel much better during daytime, full of energy. At nighttime, they sleep better. They lose some weight. And then over long term, what I'm finding is we find many of them can reverse or better manage the diseases of their gut, heart, and the blood glucose, etc. And as they continue, the inflammation levels go down, and they are at lower risk for cancer. And along the same time, what we're finding is nearly 80% of FDA-approved drug targets may benefit if they're given at the right time, and we can reduce adverse side effect. Even what time we take our flu shot, what time we schedule our heart surgery, or even what time cancer patients get their chemo or radiation therapy has a huge impact, almost 20-25% impact on long-term outcome. So just imagine, we can start a new circadian medicine around this. And then at the same time, we are also finding that in addition to training the clock or clocking the drugs, in many cancer, the clock actually breaks down. There is no clock. And if we reactivate the clock with a drug, then we can kill cancer. Just recently, in the last 6 months, we are making this discovery. So I'm really excited that the new science of circadian medicine, which is so new that most of us don't even know about it, is poised to help us to better manage, prevent and treat many chronic diseases by training the circadian clock, clocking the drugs, or drugging the clocks. And we can benefit almost billions of people worldwide who have these chronic conditions. Thank you. Thank you, Daniel.
Wow. Enlightening. You have actually a new book out called The Circadian Code. Which
Yes,
is more on this.
just came out.
Take a read. Great,
Yeah.
great book. What's one practical thing? I've got 4 devices to track my sleep. I'm still not getting enough. Many people here are jet lagged.
Yeah.
Any simple clues to improving our sleep hygiene, whether we're traveling or in normal life?
Yeah, so what I tend to say is stop eating 2 to 3 hours before your target sleep time. And that helps to reduce your core body temperature. Avoid bright light 2 to 3 hours before bedtime. And if you cannot avoid, then get a pair of these yellow funky glasses that reduces blue light. Cool temperature at nighttime. And then in the morning also, what is very important is what we're finding recently, having exposure to bright light during daytime, even an hour of bright light just walking outside, somehow helps improve your melatonin spike at night. So,
Great.
there are some 4 or 5 tips.
Awesome. Thanks
you.
so much, Dr. Panda.
Thank you.